So let's look at the first stream. In the first stream, we have the source files located in the file list being brought into the text link analysis node, which we've seen before from the text extraction videos. And we have loaded into that the Enron template. The output from that node is the list of terms that are extracted from each document. And this gives you an idea. Here are the document IDs, the terms that are extracted, the types, and important to note the boilerplate, which will be excluded from the analysis process, and the match text, just to give you an idea of the text that's being brought out. So that table is generated. The output from the text link analysis node is passed into a proprietary supernode, which is a collection, and actually a stream in and of itself, which is used to calculate and generate the top 20 most frequently occurring terms for each document. That is saved in a flat file, which is essentially an output node that saves to a file rather than displaying on the screen. And that file is being saved as top 20 terms with the date 2/11/11. That output file is being used as the input file for the next step. Now, this section, this stream, this substream here could have been just simply attached to the output, but for illustration purposes, I've separated them out. So we have now the output file being used as the input file, and let's take a look at that set of terms. And we're running that, and the table is generated, and what we see here is, for instance, the doc ID, the associated terms that were extracted, and these three fields. The first field tells us the total number of terms that appeared that were extracted from the document. The second one, the frequency field, tells us how many times the actual term in question was found in the document. And the total term is the single instance total for the terms in the document. So if a document Apple appeared 3 times, it would only be credited once under total term. So this is a single instance total. And these fields are all used as part of the calculation to find the near duplicate cluster ID and the loose cluster ID, as well as similarity. So that file, that input file, is passed through another proprietary node, which is used to essentially generate the fields, the new fields that we're looking for. And those new fields will allow us to organize the documents so that they're occurring and they're sorted and put into similarity order, and we can do a variety of things with that. Okay, now let's take a look at the effect of the clustering algorithm and what it does for us. We create a table, and the table contains the fields that we're interested in right now are the fields at the left-hand side of the table. Here you can see that the algorithm has created for each document ID a near duplicate identification value, a looser cluster identification value, and a similarity value. These are the fields that will allow us to structure the documents, to create unique representative documents, and so forth. Now, running that document set into a analysis node allows us to look at some valuable information, and that is the effect, the reduction, the document reduction in the document set. There are approximately 64,792 documents in this selection of Enron emails. When considered as near duplicate document clusters, the document set has been reduced down to 38,186 near duplicate clusters. So we've got about almost a 40% reduction in effectively in the document set that has to be reviewed or has to be looked at. And if we look even further at the loose cluster size, we have approximately 29,000 loose clusters. So the document set has been effectively reduced in terms of how much human resources have to be put into looking at the documents fairly significantly.